Welcome to AI Foundations training. Today we'll talk about AI flaws, biases, and risks. The module will ground our expectations in reality. AI is powerful, but it's not magic. Today we will learn where it fails, why it fails, and what to do about it. We will start with a clear view of AI limitations and risks in implementation. We will explore how bias enters AI systems and the practical ways to mitigate it. We will talk about data privacy considerations whenever AI touches personal information. We'll quickly explore how to spot hallucinations and also how to reduce them, and when human judgment is essential versus when automation is appropriate. Finally, we will finish with the framework to evaluate AI risks in your organization. Bias can creep in at every stage. We will explore what it looks like, where it comes from, and how to reduce it. When the models learn from flawed data, they will produce those flaws with confidence. They can be very sure and very wrong. This is called a model training bias. On the image you can see I ask AI to draw a wall clock where our hand shows 2 p.m. and a minute hand shows 40. It produced 4 versions, all of them showing 10 past 2. Now why is that? Because the internet is full of pictures of the clocks 10 minutes past 2. Here I will open the Chrome, search for a clock and images on Google, and you will see vast majority of them 10 minutes past 2. Naturally, as we train models on internet data, it inherits bias from that data. The key insight: models trained on unbiased or incorrect data will amplify those issues. Confidence does not equal correctness. There are many sources of bias. Let's walk through some of them. The example we saw with the clock is the training data bias. When a dataset skews a reality, the model learns the same skew. Underrepresented groups get fewer examples, therefore the fewer of them are reproduced by Gen AI. It's particularly applicable to web scrape text data, which often mirrors stereotypes and historical inequalities that are stored forever on the internet. The next type of bias is algorithm and design bias. The choices that we make about features and thresholds and loss functions and push outcomes are reflected in algorithm. Optimizing for average accuracy means sacrificing minorities. A proxy feature like a postcode can quietly stand for income or ethnicity. Another one is a cognitive bias in development. We are all humans, and our own assumptions creep in during the problem framing and evaluation. Confirmation bias makes us notice results to fit our own beliefs. Anchoring on an early metric can blind us to better objectives. Historical patterns often end up in another bias. If past decisions were biased, labels will encode that bias. Train on historical approvals of arrests and you will reproduce old patterns. Feedback loops then amplify the problem over time. You will see examples of it in the next slide. Lack of diverse perspectives is another source of bias. Homogeneous teams miss edge cases and cultural nuances. Data collection and annotation reflects the viewpoint of the collector. Dialects, accessibility needs, and low-resource languages are often overlooked. Last but not least, political influence and incentives, such as targets, funding, or PR pressure, can tilt the design choices. Short-term KPI drive riskier shortcuts and weaker safeguards. Policy constraint might prioritize optics over accuracy. The examples with the DeepSeek model are well documented. So that's how the bias slips in, quietly and at many points. Now let's have a look at some real examples. Here's the 4 common examples of the bias slipping in. For each one, I'll name the bias category. AWS hiring model was penalizing women's in people's CV. That was a bias category of training data plus the proxy feature design bias. The model learned from historical hiring where men were overrepresented. It treated the token women's as a negative proxy for job performance. Past labels encoded who got hired, but not who was qualified. As a result, qualified candidates were downranked. Diversity failed and the capability suffered. You can mitigate that by rebalancing your training data and remove or mask proxy features. Another one is well-documented example of facial recognition errors for darker skin tones. That's a bias category of training data imbalance and plus lack of diverse perspectives as well as a measurement bias. The data sets collected by the researchers were overrepresenting lighter skin faces. Lighting, sensors, lab conditions favored certain demographics. Design teams lacked diverse viewpoint checks. As a result, higher false positives and false negatives for darker skin. In security and policing, that risk would be unacceptable. This could have been mitigated by ensuring diversity in the data and by ensuring diversity in demographic and lighting. enforcing per-group accuracy thresholds. Next example is a UK A-level algorithm downgrading disadvantaged students. That was a bias category based on a historical patterns and algorithm design bias, as well as political and operational pressure. The system relied on a school-level history, not individual performance. Low-performing school history became a proxy for the pupil. As a result, high-achieving pupils in under-resourced schools were downgraded. Last but not least, a crime prediction reinforcing profile. This was a bias category based on a historical data and a feedback loop bias, as well as a cognitive bias in use. The training data reflected policing patterns, not the true crime rates. Over-policed areas produced more records, so the model sent more patrols to the same area. Operators trusted the map, which led to automation bias keep going on a loop. As a result, a self-fulfilling hotspot with the communities being overly scrutinized. So what lessons can be learned here? Historical data is often biased. Algorithms can amplify the inequalities collected from the historical data. You will need to do explicit fairness goals, diverse training data, and a human oversight are essential at every stage of the training model. The business impact could be reputation damage, regulatory and legal risk, loss of customer trust and talent. Prevention is often cheaper than remediation. Let's summarize the mitigation strategies. Use diverse representative training data, run regular bias audits with clear thresholds, increase algorithmic transparency and peer review decisions, and keep human in the loop for the sensitive outcomes. Last but not least, refresh and retrain periodically as the data shifts. Bias is not a one-time fix. Data privacy is by far the most common risks I'm asked about when I'm presenting in classes or in public talks. It comes up almost every time. Let's keep it simple, and here's the 5 big ones to watch. Number 1, unauthorized exposure. Sensitive details slip out through prompts, logs, or generated outputs. Someone pastes personal data into a chatbot, and the system keeps verbose logs. The model echoes the data back. The practical fix: redact or anonymize first before anything shared with the models. Perhaps use enterprise tenant where you control the network and the model. Disable chat history where possible, and of course prefer private endpoints and a role-based access. Number 2, training on personal data. By default, some services learn from your inputs. It's great for them, but risky for you. Practical move: choose the no training or enterprise options. Sign a data processing agreement with your provider. Of course, ban uploads of personal data to consumer tools such as ChatGPT. Use managed instances that don't train on your data, or use the paid solutions that explicitly state that they don't train on your data. Record the legal basis and consent when needed. Number 3, vendor data retention. Providers may keep prompts and outputs longer than you intend. Backups count for that too. Sometimes you need to take care of the backups across the region. The practical move: you negotiate the short retention windows and a deletion SLAs with your providers. You enable zero retention modules and document the vendor's retention schedule and audit it. Number 4, GDPR and the sector compliance. It's easy to stray. Unclear notices, automated decisions without humans, or cross-border transfers with the weak safeguards. On the practical side, you need to maintain a record of how the data being used. Keep a human in the loop for impactful decisions, and be ready for access and deletion requests. 5, leaks and breaches. Things like attacks, misconfigurations, or third-party failures expose data. I'll refer to another video about data leaks. Some of the AI companies that publish their solutions, they've been around not long enough to be certified for the security risks, and things like wipe coding often means solutions don't have the proper security standards built into them. The bottom line: assume your data will travel unless you stop it. You need to design for least privilege, minimize data where possible, host in a region that applies to you, and keep the retention short. Write it down, test it, and enforce it. Let's have a look at some real past examples. The Clearview scraped billions of images from the social media without consent. It built a facial recognition database from that data. Consequences were fines, orders to delete data, lawsuit, and a public backlash. The lesson: that public data still has privacy rights and the consent matters. Regulatory penalties are significant and reputation damage lasts. Let's summarize the best practices. Adopt privacy by design. Avoid sending sensitive data to the public AI tools, especially if you're not paying for them. Verify vendor privacy commitments and contract terms. Ask yourself how your data will be used or stored. Set the data governance policies. Who can access what and why? Apply data minimization. Send only the minimum amount of data you need to get sent to get your job done. Run data protection impact assessment for higher risk use. And train employees on a safer AI usage and red lines. AI can sound confident while being wrong. Let's define hallucinations and reduce them in practice. So what are hallucinations? Hallucinations occur when the models produce confident sound but false answers. Why does it happen? Because gaps in the training data, pattern matching, and rather than understanding. There's no built-in fact checkers in those models, pushing beyond knowledge limits. The examples include fabricated references, invented people or events. The model makes up product specs, plausible but incorrect explanations. Here's some notable incidents. A well-documented example of a lawyer fined for inventing case citations. There's defamation scares from false claims about the public figures. Publishers releasing error-filled AI articles, and scientific assistants outputting incorrect materials. The latest example that happened a few weeks ago was Deloitte refunding Australian government part of their fee for the report because report was riddled with AI-generated references and examples which were completely false and incorrect. Each case underscores for the need of verification. Here's some strategies how to reduce risk for hallucination. Ground your models with verified data. Pull facts from the trusted knowledge base at the query time using RAG. Pass only relevant snippets onto the prompt. And while it doesn't always work, add to your prompt answer only using the provided sources. Additional enterprise models allow switching the models only to the mode to use the data provided. Always check for citations that the model provides. Open the links and confirm them. Confirm the claims really appear in that sources. If it doesn't, treat it as a hallucination. Consider constraining the scope for the model. Keep questions narrow and domain specific. Set the temperature low for factual tasks. Perhaps disable browsing tools if you don't need them, and ban out-of-scope topics in a prompt. You can use iterative prompting for consistency. Ask the model to recheck its answers, such as list 3 possible errors or missing sources. Paraphrase the question and compare the results. See if you end up with something completely different. If answers conflict, escalate for review. Use structured outputs and validations. Request, for example, JSON files with the named fields such as answer, sources, confidence, and validate the numbers, dates, and units with scripts. If fields are missing or invalid, reject and retry. Keep humans in the loop for critical work. Define when the person must approve before the release. Legal, medical, financial, or safety content, perhaps consider mandatory review for all of those. Use a short checklist, such as are the sources present, claims verified, is tone correct. Bring specialist tools to the tasks. Use retrieval over curated corpora for facts. Use a calculators for math. Run code in a sandbox for technical answers. Use a plagiarism or reference checker for citations. Automation is helpful until it isn't. Here's where it goes wrong and how to guard against it. Common failures to watch out for. Automation bias. If you're over-trusting computer outputs because it was automated or produced by computers doesn't mean that it's correct or accurate. Another one to watch out for is a skill atrophy. Your business people lose the craft. Common example is how many more marketing emails now use emojis in headings and bullet points. Too many marketing teams sound like ChatGPT because they lost their own voice. Consider edge cases. Brittle logic misses nuances in the processes. Automation isn't very good with exception handling. No graceful out when things change. And things change in the business all of the time. Plan for the messy middle, not for the perfect demo. Despite of what we're hearing on the news, the humans are still essential. There are moments only humans should decide, such as ethical decisions and value trade-offs, novel situation with no precedent, emotional context requiring empathy, high stakes or irreversible choices. Humans are essential for creative problem solving and explaining complex rationales. Use AI to inform, but keep humans accountable for the final decision. Best results from the division of labor between AI and humans. AI handles routine tasks in large volumes. Humans handle exceptions and a context. AI offer recommendations, but humans make the final decision. AI processes large volumes of data, but humans interpret meaning and implications. How do you balance automation and oversight? Should adopt the guardrails from day one. Mark critical decision points that require human review. Maintain human skills through practice and rotation. Ensure transparency in automated steps and logs. Set fallback plans and redundancy for failures. You should automate incrementally with monitoring in place. Cultivate a skeptical mindset towards AI output. Another trade-off is the performance versus transparency. Let's unpack that. There are two general approaches: a black box AI, which is complex, high-performing, and low interpretability, and explainable AI, more transparent, easier to justify, but often doesn't perform as well. Match the approach to the risk level. Higher risk means more stringent controls and a more explainability. Black box models often win on accuracy in complex tasks, like image and speech recognition. They are harder to explain and harder to debug. Explainable models show how decisions are made. They build trust, support oversight, and ease compliance. But you need to pick the right tool for the impact and for the audience. Use this simple framework to choose the right level of transparency. High-stakes decisions require more explainability. Regulations might mandate transparency. Customer-facing systems benefit from the clear explanations. And internal optimization can tolerate more opacity. Consider hybrid approaches with the post-hoc explanation tools. Now, the last section is regulatory landscape. Here is the brief overview of the regulations to watch out for in the UK. The first one, of course, is UK GDPR, including the Article 22 that concerns about automated decision-making. You might need to revisit that. Another one is Data Protection Act 2018 and Equality Act of 2010. Look out for consumer protection laws and the sector-specific roles in your industry. And of course, common law principles still apply. Treat compliance as a design constraint and not an afterthought. Some emerging global regulation coming. EUAIAct is focused on a risk-based classification. Ban for unacceptable risk, strict controls for high-risk systems, transparency for generative AI, registrations and phased informants. It's coming into force in 2025 to 2026. UK approach is different. It's pro-innovation. It's focused on AI safety and international alignment. It focuses on voluntary commitments moving towards the standards. You need to track both if you operate across borders. 8 areas to get right in your business or department. Focus on data protection, data privacy. Implement fairness and non-discrimination policy. Take into account transparency and a user voice. Implement human in the loop for critical workflows. Always consider cybersecurity of the AI systems, including the providers you're working with. And last but not least, staff training and awareness. Use this simple matrix to rate the AI risks. Consider impact. How severe the harm if this process goes wrong? Consider complexity. How hard is it to foresee or control behavior? Combine it together to get an overall risk level. Higher the risk means higher controls and the more oversight. Let's make it systematic. Implement inventory in your business and plan the use of AI. Each of the use cases document that. Identify potential risks from bias, security, and compliance. Assess impact and likelihood with the simple scores. Prioritize controls for the highest risk items. Include diverse perspectives in reviews, including those from outside your business. Then monitor and reassess regularly as the usage evolves. If you're following this as a part of your training, in small groups or by yourself, pick one AI use case. List 3 or 5 risks that are most applicable to your business or department. Rate each of them on an impact and likelihood from 1 to 5. Choose top mitigations for the highest risks. Then share with the room or reflect on your own on how you would mitigate them. Let's review our key takeaways from this session. AI delivers benefits, but also risks, and you need to manage both. Bias enters via data and design. You need to mitigate it proactively. Treat data privacy with extra care, especially with the public tools. Hallucinations happen, so use grounding, citations, and a human review. Consider the right level of balance for your use case between automation and human judgment. Pick explainability levels based on the risks and the regulation. Implement a risk framework that fits your organization. Stay informed about evolving regulation in your sector. That's how you keep the value created and at the same time risk is under control. Thank you for watching. I included a couple more videos that I think you might finding it interesting, and I will see you in the next one.